Now we are going to solve a funny problem. So interesting, good, great problem, but by vague methods. And the problem is a solitary cube of non-conducting material, dielectric material, is charged uniformly over its volume. The vertices, that means corners of the cube, have the same potential phi. Okay, 8 corners it has got. The electric field strength vectors near the vertices of the cube outside the volume of the cube, just outside the volume of the cube, have the same value G at the corners. Okay, fine. What is the potential of the point in the very center of the cube? Okay. Now the cube was shown into 8 equal parts by 3 mutually perpendicular flat cuts. That means we are converting into 8 identical cubes. And one of the parts was removed. Okay, fine. What will be the potential of the same point in the center of the former cube? And what will be the magnitude of the electric field strength vector at the same point? Oh, let us solve it in a manner we can do it. So use dimensional analysis because integration is going to be tough, but I'm going to provide you the method of integration as well. So do it first using the dimensional method, and that means we are going to use the prototype for point charges. Potential is equal to kq by r and electric field by kq by r square type of things. And to do so, let us assume that the volume density of electric charges inside the cube is equal to rho. Well, rho, and side length of the cube as this is equal to r, simply r. So that the potential we can write here will be proportional to kq by r, and electric field will be proportional to kq by r square, and which in turn we could write potential is proportional to k rho r cube by r, and this thing turns out to be k rho r square. And in the similar manner we can do it for electric field, and in place of q we can write rho r cube by rho r cube and then divide it by r square, so that electric field is proportional to k rho r. So in this proportionality these two things are constants, and this is proportional to r square and this is proportional to r. And if we divide the cube into 8 identical cubes, what I am talking about, for each of the 8 cubes that make up the whole big cube, their radii becomes equal to r by 2. So phi turned out to be pi by 4 in that case for one of the 8 cubes, and electric field is proportional to r and their radii become r by 2. In that case E turned out to be E by 2, and now we can find the potential at the center of cube, and potential at the center of cube is the contribution of 8 cubes having potentials pi by 4 at their corners. So the result is going to be 2 pi, and electric field strength no matter what is going to be 0. And what if we remove one of the cubes, that we have now 1 by 8 of the cube, then what will be the change in potential? Then potential will become simply as 7 by 8 of phi naught. Yeah, phi naught has changed, it has become 7 out of 8 phi naught, and phi naught is 2 phi, so it will be 7 by 4 phi, and electric field will turn out to be E by 2. So because we already know E by 2 tax. Here is the electric field E. If we remove just one point from anywhere, one point, the electric field here due to the single point and the rest of the thing are equal. So E1 is E by 2, and this is not a problem. You can understand, you have solved too many problems. But the main problem is this: how can we calculate it mathematically using proper mathematics? Because we have got to colleges, schools, their buildings, paid their fees. Now, how can we do by using the methods they taught us? This is difficult, man. I'm going to set up a coordinate system at any of the corners of the cube with its axis parallel to the edges, and writing x, y, z axis. And I'm also going to assume one more thing, and it does not come at the expense of generality. There is no loss of generality at all. If I assume that the edge length of the cube is unity and charge is also equal to unity, the total charge is also equal to unity, nothing will change. And I'm going to think that I have a small volume within the cube somewhere, dV, that I should write it dx, dy, dz, and it is at a point P whose coordinates are x, y, z, right? Okay, so now I can find the potential at any corner of the cube, and I'm going to write it potential at any of the corner of the cube, and I can write it k dV upon position vector of that point, k dV upon r, like this. And because charge is unity, already considered it, and I'm going to put the limits at 0 to 1 for every x, for every y, and for every z, because cube side length is unity. So I can write here b corner at dx, dy, dz divided by under root x square plus y square plus z square, because it is placed somewhere at x, y, z, and any of the corners may be its origin. So and potential at the center, in the similar manner I can write here a k is missing, so I am going to put down the k is 0 to 1, and again dx, dy, dz, there is no problem, and this time x coordinate of the center will be x minus half. So we need to write this thing, and we can set up the ratio of integrations. B corner by B center and I can write it as well, V corner by V center as simply as dx dy dz by under root x square plus y square plus z square, and k is gone now, and so I can write here again dx dy dz divided by under root x minus half square plus y minus half square plus z minus half square. Yeah, this is the ratio, and we know how to integrate these things because if we integrate the results with respect to x, with respect to y, with respect to z alone and fuse together, we will get our result. So how do we integrate such things with respect to x? It's like 0 to 1 dx upon under root x square plus y square plus z square, and if you integrate with respect to x, then y and z are considered constants, and the result we get for this, you can find it from any table, or you can use the computer programs. I don't need. So the result will be ln 1 plus after putting the values of limits, we will get the results as 1 plus y square plus z square minus ln under root y square plus z square. Yeah, and if we integrate this with respect to y, this thing we got here, having some practice with multiple integration, you would like to write it as fyz, and then you need to integrate it with respect to y, and you will do it fyz with respect to dy, and you can integrate them to get minus ln 1 plus z square plus 2 ln 1 plus under root 2 plus z square minus z tan inverse 1 by z 2 plus z square, and let's call it gz, and then you can integrate with respect to z as simply as 0 to 1 gz dz, and you are going to get the results like 3 ln 1 plus root 3 minus 3 by 2 ln 2 minus pi by 4, and in this manner you are going to get the potential at the center of the cube without the multiplying factor k, and the center of the cube, the potential will be equal to 6 ln 1 plus root 3 minus 3 ln 2 minus pi by 2, and these are simple integrations. If you have gone through the multiple integrations and how to solve it, you can get your result easily. It's your choice now. Which method do you prefer? Thank you very much for watching.